Hi everyone. Are you feeling sleepy or stiff or anything? You want to get up a little bit and stretch? Just stretch. Yeah, stretch yourself a little bit. I mean, it's getting late. I'm feeling stiff as well. Okay, that's great. That's great. Hello everyone. Thank you for being here. It's always good to be home again and see all the friendly faces here. My name is Joe. I'm here today to share with you my work. It's called Marlin. It's a Python transpiler that transpile Smali language to Python, for Android hacking. I'd like to introduce my background just a little bit more so you get to know me better. I actually graduated as an architect in 2006. And then after practicing architecture, this is not software architect, it's like really design architect. And then I practiced I practiced architecture for quite a few years. And then I got bored. So then I picked up this programming language. It's called processing. I'm not sure if you know this, but you use it to program interactive graphics. And then I was hooked. So since like 2010 or something, I keep self-teaching myself how to program. Then in 2014, I moved to New York City. And then I started working on open source in around 2015. Just because I didn't really have anything to work on. So I kind of initialized my projects and work on them. And since 2017, I am actually the professional software engineer with a company called HeadSpin in Silicon Valley. And I like to take a detour here and start with a story. It began at midnight in February 2017. I was at Trader Joe's grocery store on East 14th Street, that's in Manhattan, and I was in shopping. I just got a job offer from HeadSpin in Mountain View. And I was ready to clock out one last time after having worked there for half a year at Trader Joe's. So I wrapped up my shift and got my stuff from my locker. And I just went over to the Captain Square. That's a place where managers actually hang out. And then grabbed the microphone. I like this one. And then that microphone is actually connected to the intercom. And then I suddenly felt this lump in my throat because I realized I was saying goodbye to the people who had become my friends over the past half year. And as I announced my departure to the whole floor full of fellow crew members, which at that time they were busy filling up the products and merchandises for the next day's customers. Suddenly, that moment was filled with confusion and just awkwardness and just surprise all over. And then just because I was sad, so I didn't want to say goodbye to anyone in person, I was about to leave Trader Joe's when something really magical happened to me. Suddenly, everybody just dropped whatever they were doing. And then they promptly stood up and then just gave me a standing ovation just as I was leaving the premise. And I'm a big guy here, but I'm not going to lie. I was actually half crying. And that remains one of the most memorable experiences I've ever had in life. And, working at Trader Joe's, that couldn't have been further away from what I had hoped I'd be doing in the United States when I first moved there. But it turned out that I learned so much from that time working there. So above all, one lesson learned is always take risks and try things outside of your comfort zone because they usually yield more interesting paths. So now I'm working with HeadSpin. We are valued at $500 million to lead the mobile testing platform. We're in Palo Alto, California. And we offer real global devices for testing and provide intelligent insights into applications that issues in real time for customers like Zynga, ByteDance, Tinder, and more. And first of all, this couldn't have happened without a sponsorship from my CTO and co-founder of HeadSpin, Brian Colwell. So thanks, Brian, if you will ever listen to this. And we are also on the lookout for aspiring engineers who want to get out of their comfort zone and move fast with us. So if that sounds like you, please get in touch after this. So that's me. I look like pretty happy working there. So let's get down to business finally. Imagine you could hack Android app in Python. Would that be cool? These are simple steps you can use to hack an Android app. First, you obtain an APK file. That's the app file. And then you use the APK tool command line to decode the app file. And then there's going to be a directory that's being created containing all the app's data, assets, and a lot of code in the Smali language. And we'll talk about that in a moment. There's some glitches here. And then next is where you figure out which Smali file to change, and you add the changes to it. And then you run the APK tool to repackage the app and install it back to an Android device, and then you hope it would not crash. So that's basically how you hack an Android app, or you reverse engineer it. What is Smali, and why does it matter? Smali is what you get when you decode an Android app with the APK tool. It's mostly used to hack the Android app and let you do all sorts of things, such as like adding lock statements to the app or overriding security mechanisms of the app. So basically, every Android hacker's favorite language, Smali. Well, I'm not sure about the favorite part, but it's the only option so far. Marlin makes hacking Android apps pretty easy by transpiling Smali to Android. To Python, excuse me. So as you can see, man, that's bad. So it's a transpiler that transpiles Smali language to Python language, so it's more readable and easier to reason with. So while we're waiting for this to be resolved, there's a bonus question. Anyone knows what a transpiler is? Okay. Anybody else? Anybody else ever heard of Transpiler? You're not wrong. A transpiler is a program that reads source code in a language and maps to a source code in another language, usually a higher level language. Examples would be TypeScript, that's a transpiler to JavaScript. And Nim, that's another transpiler that can transpile Nim language to JavaScript. And also there's this language called Ocaml that also can be transpiled to JavaScript. Okay, obviously I need some savings as much as JavaScript itself. And of course, we can also transpile Smali to Python language using Marlin. Okay, here's an example of a minimal Smali code. It represents a Java class, mat, with two static methods, add and subtract. From here, it isn't hard to guess what mat does, but it isn't easy to do so with more complex Smali code. Okay, I think we have to keep blinking so that we can sync to this glitches. And to the right, you will see the Python class generated by Marlin Transpiler that I wrote. So you can see it's just pure Python class, and it's totally readable compared to the equivalent Smali class. So we're gonna dive under the hood and just get to know Marlin just a little bit better. Marlin, just like any other compiler, is roughly divided into two parts: the front end and the back end. All right. Oh, seems like it's getting better. Okay. Okay. Let's carry on. So the front end of this transpiler is responsible for scanning and parsing the Smali source file and creating an abstract syntax tree, or the AST. We're going to talk about that a little bit more later. The backend is mostly responsible for cleaning up unused nodes of the syntax tree and transform or map the Smali tree to the Python tree and generate the Python code in the end. So the first stage in any interpreter or compiler is Lexing, or scanning. In this stage, we care about fetching tokens of meaningful words, or lexemes, and we define a type for each token to make it useful for parsing. Based on a certain set of match rule, as you can see there in the bottom left right there, we can actually use the scanner to match our source code. Let's go through that Smali code a little bit here. The first line there is the class header in Smali. The scanning part, the scanner actually sees .class as a class keyword. Then it keeps that. Then it sees public as the access modifier, and it keeps that as well. And it goes on to cladder semicolon, and then it treats that as an object. And then at that part, it should meet a new line character, and then it moves on to the next line. So we keep doing this on and on until our scanner meets the end of the file. And then we carry on to the parsing state that creates the abstract syntax tree. As you can see here, this tree here is a representation of the Smali grammar. For instance, this is the top level module of the Smali. And in turn, the module requires a class definition and an end of file. In turn, the class definition expands to the class header that we have seen previously. And then it requires 0 or more class statements, and then a class body. The class body itself is just a list of method definitions, and so on and so forth. And the parsing just keep going down this tree until it hits the leaf nodes, which are normally tokens, something that cannot be expanded anymore. I'm showing you a variation of, I don't even know how to pronounce that. Okay. Well, thanks for helping. It's called a buckus nor form. Usually I'll just refer to it as BNF. So BNF is just a way to formalize the context-free grammar when you have to write a parser for a compiler. And you don't have to understand all of this, but it's really fun to learn how it works. Personally, this is my favorite part of writing an interpreter or a compiler. It's happening again. So as you can see there, that's the rule of the BNF. In the left-hand side, you have a name or a symbol. And then you have this odd symbol, a double colon, and an equal sign. And then to the right-hand side, it's a clause that can be expanded to match whatever's on the left-hand side. That odd symbol means may expand to or maybe replace with. Personally, I like the second one better because it sounds more descriptive. And in the white box, that's a limited BNF for a really lame calculator that can only add integers. The notation here actually reads an expression, maybe replaced with a terminal, a plus sign, and another expression. Or it can be just a standalone terminal. And then we define a terminal as just an integer token. And we finish it right there because the integer token cannot be expanded anymore. So let's explore the cases here. As you can see here, we have one here that matched the color of the terminal. That's the terminal and the plus sign. And 2 plus 3 is the valid expression. Because if you can see here, the expression is recursive. The expression here itself can be expanded into a term, a plus sign, and more expression. So it keeps going on and on. Next case is, let's say 10 plus 1. 1 is a standalone terminal, which is also a valid expression. So that's a valid syntax for our calculator. And obviously, a standalone number or integer is also valid because we say that the expression is also a standalone terminal here. As you can see here, this calculator can infinitely add more and more expression to a series of calculation. In theory, you can just keep adding more and more expression because 1 is a terminal plus 2, that's its expression, but 2 plus 43, it's also an expression, and so on and so forth. Pop quiz. Who talks like this BNF grammar? A, Yoda. B, Groot. C, Mickey. And D, John McClane. By the way, if you can speak John McClane's tagline, you get points for this as well. Anyone care to guess? It's just 4 choices. Yoda? Anybody else? Anybody else? No? Are you sure? That's right, congratulations. So Yoda liked to say something like, may the force be with you. That's auxiliary verb and an article, noun, verb, preposition, and subject. Or something like lost you are, which is expanded to adjective, subject, and verb. And lastly, the transformation or the code generation stage. That's the last stage. This stage maps the Smali tree to the equivalent Python AST objects. Fortunately, Python standard library already includes the AST module, which provides out-of-the-box classes for all the tree, the Python tree it needs. So I didn't really have to implement this from scratch. If you can see here, within the red box, that's the module level. You'll see the st.module constructor here. That compared to the generated Python code, that's the module. Within the yellow box is the body of the module, which is a class definition. And that's the class definition here. And lastly, the blue box, that's the body of the class, which is just a list of 2 function definitions or method definitions. If you map it to the right-hand side here, you'll see that they have two methods here, add and subtract. So to get this project rolling, I've set a few milestones for myself. So at this point, Marlin is able to generate correct Python code up to 90%. The next goal is to support Python 3 type annotation. It's getting started, but this is a very interesting feature because Smali is itself a type language. The next goal is to compile Python back to Smali, but that's going to be a different project. And next, I want to expose direct API to the Smali tree, so the Python code can programmatically change the Smali tree or the syntax without having to generate the Python code. So at times you don't want to read the Python code that Marlin generates. You just want to write code that manipulate the Smali syntax tree directly. And lastly, I want to open source this library or this Transpiler, and I'm in the process of negotiating with my company. I like to leave with a quote from Zig Ziglar. You don't have to be great to start, but you have to start to be great. And thank you everyone for your time today. Thank you very much. Before the Q&A, if anyone would like to connect with me, here's my GitHub profile. I'm also on Twitter with the same handle. That's not my profile picture. It's just a random cute llama right there. Anybody has a question so far?
Is there a question?
Yes.
So since Marlin is not a finished product, how do you work with Smali?
Could you repeat the question?
How do you work with Smali if Marlin is not a finished product?
So right now, it can, thank you for asking a very good question. Right now, it can transpile 90% of the Smali code to Python correctly. Yeah, but the next goal is to be able to compile the Smali back to Python. So in that case, you can just write Smali in pure Python. But right now, you can just translate Smali to Python, but there's no way to actually translate Python back to Smali yet. So you can start using that feature right away, but the other way around is still a work in progress. Yes?
How do you test the correctness of the transpiler?
So you're saying that how do I verify the correctness of the transpiler, right? So at this point, it's just writing a lot of unit tests based on a lot of Smali code that I actually parse from the decoded Android apps. So right now, so far, I've run Marlin transpiler against around 500 Smali codes from 100 apps, Android apps. And so far, the tests still pass. So, but the thing, when I said that is only just 90% correct, is because there's no way for me to be sure that with just the sample of 500 Smali code would be enough to guarantee a full correctness of the transpiler. Thank you.
So, does anyone have questions still? Don't, I think we still have time. So, Joe, I have apologized about all the projector problem. So I hope it's not a problem.
No worries, no worries. Yeah, I mean, we all have to cope with uncertainty, right, in life. So it's totally fine. But thank you very much for all your help today. Thank you, everyone, for being here. I really appreciate you guys.
Thank you.